Welcome back to Scholar Strive. Doing some math. Today we'll be working with inverse functions, or just inverses in general. Hope you had a good Thanksgiving weekend. I did. Here we go. Inverse relation. Basically, an inverse relation means that you the inputs of a function and outputs switch. Whoop. Send to the back. Switch. Domain. What's wrong? Domain and range also switch. My pen, please stop. Okay, so let's do some examples. We have an original relation. We have x table to y table. Now, because we just have an x and y table, no equation. Our domain is just the x values. Now, I've been noticing a lot of you guys have been just making a table. It's like, oh, this is my domain. If your x values go forever to the left, it's negative infinity, and then if it goes all the way to the right, it's positive infinity, so negative infinity to infinity. In this case, it's just 0, 1, 2, 3, 4. And then your y values for your range, 6, 4, 2, 0, negative 2. And if we graph this, we have 0, 6, dot there, 1, 4, dot there, 2, 2, dot there, 3, 0, 4, negative 2. So obviously there is a pattern to this one. So our domain in range would probably be negative infinity to infinity, but we don't know that. We don't know if there's a stops there, or if negative numbers don't work, or whatnot. Now let's look at the inverse relation. All we do is switch the values. So instead of x being 0, it's now 6, 0, 4, 1, 2, 2, 0, 3, and negative 2, 4. So all I did was switch them. Okay. So let's graph these. So 6, 0, 1, 4, 2, 2, 0, 3, and negative 2, 4. Okay. Drew that line pretty incorrectly, but that's okay. Let's move on. So how to find the inverse relation given an equation? You just switch x and y and solve for y. Inverse reflections are reflections over the line y equals x. So if I drew y equals x, you would notice that they're reflected along that line. So, okay. Let's do some examples. And oh yeah, there's a third step. Change y into f inverse of x. Okay, find the inverse relation of y equals 3x minus 5. So first thing we gotta do is switch x and y. So step 1, switch x and y. So x equals 3y minus 5. Okay, and then solve for y. So to get y by itself, I'm going to add 5 to both sides. So x plus 5 equals 3y. And then I'm going to divide both sides by 3. So I get y equals x over 3 plus 5 thirds. Okay. And then lastly, to make this perfect, f inverse of x equals x over 3 plus 5 over 3. Okay, so find the inverse relation of f of x equals 3x squared. Now, don't freak out. This f of x just means y. That's all it means. So we're going to switch x and y. So we got x equals 3y squared. And we take x divided by 3 to both sides. And then we have y squared, and then we're going to square root both sides. So y is equal to the square root of x divided by the square root of 3. We don't like having radicals in the denominator, so we'll multiply top and bottom by the square root of 3. So I get y equals square root of 3x over 3. Because the square root of 3 times the square root of 3 is 9. Square root of 9 is 3. And then lastly, f inverse of x is equal to square root of 3x over 3. Okay. Inverse functions. Functions f and g are inverses of each other, provided that they do this. So if you do f composed of g, which is f of g of x, and that equals x, and g of f of x, that equals x, that means they are inverses of each other. The function g is denoted as f inverse. Yeah, so I said this is f inverse. Okay. So when I say f inverse of x, that's f inverse of x. Okay. Next page. Okay, let's prove that functions are inverses of each other. So in order to do that, we just do f of g of x. In this case, it's f of inverse of x. And we should get x. So let's do that. Okay, so remember when we're doing this, we're going to do the inside function first. Well, since we're not plugging anything in, we're just plugging in x. I'm going to plug this into that. Okay, that is my f of f inverse of x. So I have 3. So that's what my f function starts off with. And then x is now 1/3 x plus 5 over 3. And then we have minus 5 from our original equation. Okay, distribute this through, and I'll get x plus 5 minus 5, and I'll get x. So that works. Okay. But now, I need to do the other one. Okay, so I'm going to erase this bit. Whoop. Erase this bit right here. And go the other way. Okay, now I'm going to go put this into there. Okay, so this is f inverse of f of x. So 1/3 of my 3x minus 5 plus 5/3. Okay, sorry, that looks... So 1/3 of 3x minus 5 plus 5/3. If I distribute, I will get x minus 5/3 plus 5/3 So I get f inverse of f of x equals x. So that they are inverses of each other. Next, f of x equals square root of x plus 2, and f inverse equals that. So let's see what happens. So first thing we're going to do, plug this in here, into x there. So the square root of x, which is x squared minus 2, and then plus 2. So that was in parentheses there. Okay, I can remove the parentheses because nothing's being multiplied or subtracted or whatever. We're just adding and subtracting. So this becomes the square root of x squared because 2 minus 2 is 0. And the square root of x is x. Okay, so that one works. Now we're going to go the other way. Plugging this into that. Okay. So we have the square root of x plus 2. That's in parentheses squared minus 2. Square root and squared cancel, so I get x plus 2 minus 2. X equals, or sorry, it's just x. 2 plus 2 minus 2 is 0, so x. So that, boom, boom, they are inverses of each other. One question that might be asked is, where's my plus or minus? I did not create these square roots myself, so we're just looking for the singular answer. There's no plus or minus there. Okay, next. Vertical line test. So we have a vertical line test and a horizontal line test. Vertical line test tests to see if f itself is a function. So what the vertical line test, let's say I have x cubed here, which looks something like, or looks something like this. Okay, my domain and range, all real numbers. And does the horizontal line, or does the, well, first off, does the vertical line test work? That's to test whether it's a function. Basically, how the vertical line test is, you just choose any point, and you should not hit more than one point when you do the vertical line test, and that'll prove it a function. It's a function. And it's true. You only hit 1 point in x cubed, so it is a function. Now the horizontal line test to see if the inverse of f is a function. So we don't know what the inverse of f is. Well, if I wanted to do it, so if I had y equals x cubed, I would switch it, right? X equals y cubed, and then I would do y equals the cube root of x. Okay, but if we wanted to see if the inverse is also a function, we just draw a horizontal line test anywhere, and you only get 1 point. Even there, when it looks like it's horizontal, it is horizontal, but only at 1 point, which is 0. So it only intersects the graph once. So this one's a yes. Inverse is a function. And then this one, let's say we have a quadratic. Boom. Boom. More U-shape. Whoa. This one doesn't pass the horizontal line test because it touches 2 points there. So no. inverse is not a function. Okay. Example 5. Consider the function 2x cubed plus 1 is determined whether the inverse of f is a function, then find the inverse. Okay. Well, let us see. So you would graph this. So you would graph this function, and you would realize this is very similar to, well, I mean, it is a cubic, so it does something like this. And it passes the horizontal line test, so you say, yes, it does. So that was the first part. And the next part, switch x with y. So you don't have to do this if it's not if the inverse is not a function. But here's the inverse. We switch x with y, so we get x equals 2y cubed plus 1. Solve for y. So I get x minus 1 divided by 2 equals y cubed. So I skipped a step there. I subtracted 1 and then divided by 2. And now I'm going to do the cube root. So f of negative, or the f inverse of x is equal to the cubed root of x minus 1 over 2. Okay. And then we look at domain and range of each of these, and if we and if they're switched, then they work. So the cube root of anything can be anything. There's no restrictions. X can be negative, or the radical, the number under the radical could be negative. So our domain and range for both of these is all real numbers. Domain, all real numbers. So this is the quick way. If you can switch domain and range and you get the same thing for both equations, then you're good. Otherwise, you do the compose. The compose function, see if they work. Example 6, 5x squared. So we got a U shape, so no, it doesn't pass the inverse test. If we wanted to find the inverse, this is what would happen. Switch x with y. So I get 5y squared. Divide by 5, so I get x over 5 equals y squared. And look what happens. I take the square root of both sides. That means plus or minus comes into play. X over 5. I could fix this up, but we're going to stop there. Okay. If we switched our domain and range, would it still work? No, because x cannot be negative, otherwise we have imaginary numbers, and doesn't fit into our domain or range. And that's how you find inverse. Switch x and y, solve for y, change y into f inverse of x. And that's it. Have a good day.